I'll keep the recording. All right. Welcome everyone to the first meeting, I believe, of the new year. Happy New Year to everybody. Let's jump right into it. I don't see any new faces, so I'm gonna skip over that one for now. And move straight into outstanding RFCs. I can also share my screen if that's helpful. If this will load sometime today. Given that, I'm thinking it might not be a great idea for me to share my screen. My Zoom is being a little laggy right now. Would someone like to run us through the outstanding RFCs?
I can do it.
Thank you.
Does that look big enough? All that? All right. So starting from the bottom, stack build materials is still blocked. Yes, I assume. Great. Okay. Forrest is not here to talk about source removal. This poetry draft is still in progress. Is that right, Tim and Rob? Great. Okay. So then next we have this RFC for secure runtime environments, and similarly this one about shell-specific interfaces. Sam, I saw that you added these to the other part of the agenda. Is there anything you want to flag now before we get into it later?
No, we can talk about it later.
Okay, fair enough. So then next I see we have an RFC to move from Buildpack YAML to environment variables for configuration for PHP. What's the deal with this? Any updates? Okay, I see some conversation here. I'm not too up to date on this RFC.
I think Forrest was looking for feedback from PHP maintainers.
Got it. Okay, so that looks like Dan Mancusa and Tim.
Yeah, I personally haven't had a chance to look at this yet. I will do that though.
Okay, sounds great. Let's pop back out of here. And then lastly, this came in about a half hour ago, a proposal to alter the order of the Paketo builders. Anything you want to say about this, Dan?
I think it's pretty straightforward. There's just some use cases where we're seeing false positives where the node Buildpack detects when it shouldn't. So we're suggesting this as a possibility. I definitely want to get feedback though and see what people think. I'm not really sure. I did do a little bit of reading into some past discussions on the Buildpack order, but I'm not sure we have like a process for what dictates the order or how changes go. So curious, just feedback all around.
One thing I noticed here, I'm seeing this, is it looks like this RFC is in the top level directory and thus is subject to review by the steering committee. Was that intentional, Dan? As opposed to being in the builder subdirectory?
So my intent with that was to have the broadest audience possible because changing the order could impact multiple build packs. So I wanted build pack teams to see it as well as the builder team.
Cool, makes sense. All right, so take a look at this one. Just about anyone, it sounds like, because the change in this order might impact an app that your language family is currently building in the builder. All right. that's all of the open RFCs right now, with the exception of these that we'll get into in a minute. So I'll stop sharing my screen now and hand it back to our master of ceremonies, Tim.
All right, thank you so much, Frankie. Next up, I see overview of preliminary Java ARM64 support. Or actually, sorry, I skipped over the project update. Not sure if anyone has anything to say about that one item there.
I think usually we add whatever is in flight, but since most of us are coming off some holiday, there isn't much to discuss. I just added this one item, which is something that Frank and I are working on right now, but we don't have too much to add. It's just letting people know what we're up to.
Cool. And so with that, the overview of preliminary Java ARM64 support looks like Dan, maybe.
Yeah, so I got a little bit of spare time to look at building Buildpacks on ARM, and I was actually able to find some free hardware to use to test things out as well. So that worked out nicely. I just wanted to, I can share my screen, just share quickly what I came up with, and then also just kind of the general approach that Sophie and I had been discussing about how we move forward with ARM support. 1 second here. All right, so just in general, you know, what Sophie and I have been discussing about like a path forward on this, because there's just a lot of things that have to happen, was trying to kind of get to a spot where we can give some instructions to users on how they could build their own build packs. So, you know, everybody wants us to publish ARM images. We want to do that, but there's a lot of steps to get there, and that's going to take time. And so in the meantime, I think what we're trying to do is enable users that are, I guess I would call early adopters. They might feel otherwise, but we're trying to enable them to build their own build packs, builders, etc., that they can run on their ARM machines. And so we kind of feel like that's a first step. It's easier, it's a little more attainable, and we don't have to, you know, it sidesteps some of the challenges for us, like how we distribute and how we build these things, since GitHub Actions don't have ARM builders yet and stuff like that. So what I went through and did was just put together some kind of instructions on how I built things manually on an ARM box. And then I kind of took a second pass and wrote some scripts to automate some of the more annoying parts of that. And what I came up with was this repository that I shared in the ARM channel, and it has some instructions and stuff. It's specific to the Java set of build packs because it takes advantage of some of the tools that we use, but I suspect that it would be not that much of a difference to use with other build packs. It would probably just be using Jam instead of the tool that the Java team uses. But this is kind of what's out there. You know, it walks you through installing the prerequisites on your ARM machine. Everything that I needed would seem to have ARM binaries available. You know, so you can get the pack CLI. I did have trouble with the pack CLI because while they publish a release version for Macs, they don't publish a release version for ARM64 Linux. So I did have to compile that from source at the moment. And then it just kind of walks through the basic steps of creating your ARM stack, and then packaging up the build packs. On the Java side, we're pretty lucky. There's not a lot that we have to do. The number of native binaries that get installed is fairly small. You know, we installed primarily the JVM, but Sift and WatchExec are the other two, and that's really it. So For us, it wasn't a lot of changes, but basically, you have to go through the Buildpack TOML for those, find native binaries for ARM that can be downloaded, and then update SHA hashes and things like that. This repo has some examples of that. Those will obviously fall out of date because this repo is not being updated as versions change and things. But again, it's just meant to be an example that people can use to see the process. And then there's some scripts that will basically just walk you through cloning all the build packs that you need and then building all the images. Again, it's just kind of automating, some of the stuff that you could manually walk through and do, but it just makes it a little bit faster. And then at the end, you end up with a set of ARM64 build packs, build pack images, and then you can package those up into a builder. And I did some testing with our sample repo, and the various Java apps all built and ran fine for me. I was able to verify that they're that ARM images and things like that. So it seems like it's the net result that people want. It's going to take a little bit of effort if someone wants to go down this route, but it's kind of a way to get there in the meantime till we, as a project, get more automation in this area.
This
Any
is
questions?
awesome. Thank you for documenting all the steps. Have you been able to get any feedback from any of the people who were interested in this so far?
I'm hoping it's just because of the holidays, but I haven't really heard much yet. The amount of comments we got on this, I felt like people would jump on it quicker, but again, it might just be the holidays, so we'll see.
Awesome.
Oh, and if you are looking to toy with this, the free hosting that I found is through Oracle Cloud. You can get a personal account, and they have ARM VMs that are in their free tier. So.
Cool, thanks, Dan. Were there any other questions about ARM64 support?
Quick clarifying question about what, like, the proof of concept that you put together, Dan, which is the sort of like resulting image that comes out of that pack build. That is an image that can run on an ARM node. Is that the idea? Like if your K8s cluster had an ARM64 node?
Yes. Yeah.
Cool.
Yeah, and I think primarily where we're seeing people ask about this is with the M1 Max. At least for the Java world, building Java native apps takes like 10 times longer when you use the Intel images. If you use the native ARM images, it's like significantly faster. So.
Cool. If there are no other questions, we can move on to the next thing here on the agenda, which is listed as different build/run user.
Yep. I can just share my screen as well. So some background around this RFC. It was motivated by this upstream RFC and spec change, which recommended that the base build image and run image use different UIDs and possibly even different GIDs for the users in order to ensure that whatever artifacts are being put into the output image during build time cannot be modified during runtime. The motivation for the upstream RFC was mainly security related. Good example of this is like the most recent Log4j vulnerability, I believe, which was patched by 2.17.1 involved like runtime modifications to the config file to revert it back to like a config version that was vulnerable. So it's more mainly like preventing modifications to trusted artifacts that could have potentially like significant impacts like further on in the runtime. So like this is also the typical practice when building Docker images, like using Dockerfile, you would create or put certain artifacts using the root user and then switch back to a non-root user, which cannot modify system packages or things like Python interpreters or the Node runtime. The reason I've put it back into Paketo here is because most of the Paketo builders right now produce images that can be modified during runtime. And although that's not really an issue if you use the Buildpacks with a different set of base images rather than using the ones that Paketo ships with. There are some Buildpacks that rely on this property of being able to write or modify artifacts during runtime, which sort of breaks this whole thing if you're using the Buildpacks individually, even if you're trying to use a stack that has a different runtime user. So it's partly twofold. One is to prevent like Buildpacks that are trying to modify artifacts during runtime. So like if they're updating files in the output app workspace or using things that they cannot write to and then erroring out. And then the other subsequent one is to update the builders themselves to have different UIDs or GIDs, depending on whatever the rest of the project finds necessary, so that we could have secure builders from the Paketo project itself. So there are like two different outcomes to this RFC. I'm mostly interested in the former, which is like having Buildpacks that, if necessary, can work on stacks that do follow this recommendation upstream. Some examples are like the Nginx Buildpack from Paketo, for example, modifies the config, the Nginx config during runtime to inject certain environment variables or update included config files and things like that. Yeah, that's the overview of this RFC.
It strikes me that there maybe is like two parts to this. The one is like in our stacks to actually create stacks that have different user IDs in order to like conform with the existing RFC that you outlined as motivation for this. And then the second part is to like ensure that our Buildpacks actually function once that change has been made. Do you have something that outlines the stack change as well, or did I miss that?
No, this was just the Buildpack change, so that we could first modify the Buildpacks and make sure that they could possibly work with such stacks without affecting any user behavior. Because when we change stacks with different build time and runtime users, like that might potentially impact how users are using or like their applications and so on. So this was just to identify Buildpacks that do rely on a behavior where they're like modifying or writing things during runtime and use things like temporary directories or things that they know that they can write to, like maybe the home directory or like some other configurable directory. And then once that is done, then we can think about like modifying these stacks and producing new builders. So this is just the Buildpack specific RFC. It's just to isolate build packs that are not, that essentially don't follow this behavior, even if you use them on a different stack. And then like once we have fixed all of that and like maybe tested it with a stack containing different build and runtime users, then create the appropriate builders.
I think one of the challenges with this that I see is not just getting the build packs to comply, but getting the software the build packs install to comply. And that's harder because it's harder to flush out the cases where those are doing that. I know we've done some of this work with the Java build packs, and it's been difficult to test and catch. Usually we're finding the problems in the field somewhere and then fixing them as we find them, because it's unpredictable. When something is some piece of software is going to assume it can write logs to the current working directory or something like that. That would be my only concern. It's just, I think we can guarantee the build packs themselves don't do things like this, but runtime is going to have to be a lighter guarantee. Like, we'll fix what we can.
Yeah, so like, as I said, that change I think would come in when you're actually modifying the stacks and builders. Like, even if you modify the build packs to have the safe behavior right now, that shouldn't impact any applications. Once we change the builders to the new ones that have different UIDs and GIDs is when it might be a larger breaking change to the actual users. As this RFC currently stands, it shouldn't have any, hopefully shouldn't have any like application facing differences for users. Like if they are currently writing things in the current working directory during runtime through their application, like not through some execd or some initd scripts, sorry, profile D or execd scripts, that should still work. It's just that build packs should not rely on that assumption when they're like doing their build process or creating execd scripts. Does that make sense?
Yeah, I think so. That's kind of what I was getting at. Like, I think we can guarantee the build packs won't do that, but if a build pack installs some binary, we can't really guarantee what that binary does.
No, that seems fine to me. I think like so personally speaking, the way we use Paketo build packs are as libraries, and we add certain modifications on them so that they're using different binaries and maybe different stacks. So the main motivation behind this RFC was to make sure that the build packs themselves were not making such modifications during runtime.
Okay. Are you planning on submitting a second RFC for the stack change that you discussed? I just wanted to clarify.
I can. I just wasn't sure like whether the project would accept that. Like, this was a non-impacting change. Like this should have no impact to Paketo users. The other will. So I can submit an RFC if you like.
I don't have a strong preference which way it goes, but I would prefer it to be spelled out somewhere. So either in this RFC or a separate RFC. I don't know, Ryan, do you have any thoughts? What do you prefer?
I mean, I think it would have to be a separate RFC, just because I think that like it's entirely possible for us to make the change that Sam is suggesting we do here, and then never actually have different user IDs for the stacks that we ship. And that would be probably from Sam's perspective completely acceptable. It sounds like, Sam, you're using totally different stacks anyway, so what we place for our stacks is not really important to you. But yeah, I personally think that it would be better if we had different users. I just worry about exactly what we're talking about, is that that'd be like a major breaking change for users that are maybe inadvertently relying on that behavior.
So even during the upstream RFC, we had, like, just for some background, we had some conversations around this. Heroku, for example, originally used to do this, where they made their applications read-only, but then they had way too many issues with users doing like assuming things are writable during runtime and their application's not working, that they just decided to revert that change back. That being said, like the RFC was still like accepted, and the project still recommends you have different UIDs and then rely on GIDs instead to explicitly mark out directories or folders that the application can write to during runtime. So it's not completely removing the possibility of runtime modifications. It's just making sure that what you can write to during runtime is like very specific limited locations. So if, for example, there's a random node application that expects to create some cache files in its working directory, maybe you can like specify a buildpack to say that, okay, these directories are marked as writable during runtime or something like that. So it's like an explicit operation where the user opts into saying that I want these directories to be writable during runtime, rather than saying that, hey, I want my Python interpreter or my node runtime to be writable during runtime, which doesn't really make sense. Like you don't want to modify your Python interpreter and like system files during runtime. But like, yeah, that was a more user-facing change, and I don't know how Paketo users like generally rely on such behavior. So didn't feel like I was in the best place to write that RFC.
Given that it's kind of up in the air whether or not Paketo would release stacks that sort of like conform to that recommendation, I'm sort of wondering if there's any other way that we can test or enforce this requirement, basically, because it's one thing to accept this RFC and then sort of retroactively fix build packs that already exist. But if there's no like if the stack itself is not gonna like enforce this rule for future build packs, then what mechanism do we have to ensure that this will be true for future build packs?
I mean, we can definitely create test-only stacks that you can. I'm assuming there are some integration or end-to-end tests that run on a different set of stacks or builders than the ones that are shipped to users. So those could potentially have different UIDs and like different runtime and build time UIDs. But again, I didn't want to make any recommendations here, but happy to update the RFC as how others see fit.
It's worth considering that come April, we're going to have a breaking change in our stacks anyway, which is that we're going to move to the LTS for 22, which is JJ. So it may make sense for us to make like more than just the base OS as a breaking change at that point in time, and say from that point on, those things are have different user IDs. We might also want to consider something like some sort of utility build pack that allows users through, say, like a configuration file to say, like, please whitelist these directories as writable. But I think we should continue this conversation probably in some sort of discussion or offline as well. It sounds like there's a lot of nuance there.
Yep. I was just hoping to kickstart the conversation for this RFC and maybe have some comments on like these details on how the specific RFC might be implemented. I know Daniel left some comments, but it was more like, how do you implement this RFC rather than the specifics of the RFC itself? So I don't know if like
One of the
yeah.
One of the only other questions I had was beyond, like you mentioned that the Nginx build pack has this particular issue. That's the only one that came to my mind when I first read through the RFC to begin with as well. Have you seen other instances or things that, rather than us going to every build pack and trying to audit it for this particular scenario, just things you've seen that maybe help point us in the right direction just to begin with?
I think the main places to look out for are like profile D and exec-D scripts. Everything else is application territory.
I suspect PHP will be impacted.
And in terms of applications that may not work after this, like if you go through the stack change, I mean, it's completely arbitrary. Seen maybe Node sometimes creates, depending on the packages you install, create some random files in the Node modules or Node cache directory at times. So, and that was like a one-off use case with certain packages. So it's again very application specific, but in terms of Buildpacks, it's mostly just exec-D and profile D scripts.
All right. Anything else on this?
For what it's worth, like we've been using this with secure stacks for Go, Python, Node. What else? Java maybe, and it works fine for us, but we have a very specific platform that we control, so may not work the same with all users. But just to give you some context, like we use like the Paketo Buildpacks as libraries, switch out the assets, but everything else is the same and it works for most applications.
Cool. If there aren't any more questions, we can head down to this next agenda item, which is exec-D / direct processes.
Yep, this is also motivated by an upstream RFC around removing shell-specific processes. I believe this is slated in for the next Buildpack API release. The idea is that the upstream spec will be completely removing any dependencies on Bash or shell in the lifecycle and in the Buildpack API. There are a bunch of reasons why the upstream RFC does a good job of highlighting the removal and the sort of new API and alternatives that would be introduced to preserve certain common functionalities, like using environment variables in the start commands. The reason I bring this up in here is there are certain Buildpacks that rely on the tiny stack, like they hardcode the tiny stack ID to enable direct processes. And there are also like some weird interactions between direct equals true and profile D scripts. So if for whatever reason there's a process marked as direct equals true, it actually does not execute any profile D scripts put in by that buildpack. It just leads to random bugs in buildpacks. It's a weird and slightly unintuitive behavior, but it happens because if you set direct equals true, the buildpack just assumes there's no shell, and if there's no shell, then you can't run profile D scripts even if there is a shell. So again, this is motivated by the reason why I put this RFC is we use things like the Go buildpack, and that specifically hard codes the tiny stack, the Paketo tiny stack, to set the direct flag to true, even though it doesn't really need to, as far as I can tell. It doesn't have any shell specific dependencies in there. Might be the case with a bunch of other buildpacks, but that was like the specific one that we hit an issue with. Although I don't really know how many buildpacks are compatible on the Paketo side with the tiny stack. I just know of JVM, native, and Go. I don't know if there's anything else that explicitly works on the tiny stack. But yeah, that's this RFC. I think the main benefits to Paketo for implementing this is profile D and shell scripts are currently slower. So even while the upstream spec changes and API changes are being made, I think it might still be useful to remove direct equals false in all the places that we don't need it.
All right. Are there any questions? Doesn't seem like it.
I had one question out of curiosity. Why does the Go buildpack set direct equals false by default? Like, is there any backwards compatibility reason or something?
I would have to review what originally was around that change before I could answer that question.
Yeah, that's pretty much it. I think it might also be useful to go through a bunch of like both of these RFCs, given the whole bunch of stack related changes that are going to happen upstream where stacks are going to be completely removed. So like any buildpacks that explicitly rely on stack IDs to trigger certain behavior. Like I don't know if there's a we don't even have a plan upstream on how to handle those kind of migrations yet, but just FYI.
All right, folks. Is there anything else not here on the agenda that anyone would like to speak to before we adjourn? All right. Take that as a no. Cool. So this has been a working group meeting for this week, and I will see y'all in the next one.